The flip side. Okay, this is a new report out from, let's see. Well, this is from NPR, and they found, well, not NPR. Let's see, who did this? Someone found a giant kauri tree in the Waipoua forest in New Zealand that had been preserved in a bog for like 40,000 years. And it had some evidence that tells us about when the Earth's magnetic field flipped. Let's see. Well preserved. The last time it flipped was about 42,000 years ago. Around the time of the extinctions of the Neanderthals and sudden appearance of cave art. Coincidence? Probably, but not necessarily. Let's see. Geologists have noticed that die-offs of large animals appear in periods when Earth's magnetic field was weak. So what's happening? Okay. Our Earth, the thing that presumably we're stuck to right now, as you're listening to this, has a giant churning iron metal core. Well, it has a solid metal core, and around it has a liquid metal sloshing around. Let's see if we can get to a picture of what the Earth looks like. First, here's a picture of the actual tree. This I can't even pronounce what this says here. A kauri log from a swamp in New Zealand. This was unearthed at Top Energy's Nagawa geothermal power station. The tree, 60 meters long, weighing 16 tons. Blah, blah, blah. Excavated. Okay. And it has carbon in it from a time when the Earth's magnetic field was going the other way. So we don't know too much about there. This is like a relatively new concept that we have learned that the Earth's magnetic field can flip, and probably has a few times in its billion-year-old history. I think I saw that estimates are like every 200 to 300,000 years, the whole sloshing around insides might flip over, and that means the magnetic field around the whole Earth is going to flip. Or, more likely, when it is on its way to flipping, it's going to become weak and sort of turbulent and sort of moving all over the place. This quote says, this is talking about 40,000 years ago. The North Pole did wander across North America towards New York, back again across Oregon, and then zoomed down through the Pacific really fast to Antarctica and hung out there for about 400 years. So there were people around back then. This 40,000 years ago. Humans probably weren't in North America yet, but they were in Africa and Europe and Asia. Neanderthals were around. They might have been hanging out together. And the Earth went weird. This would have probably been a very bad time to be hanging out on Earth. Here's a little description. Well, the ozone layer would have been affected, would have taken a beating, as this says. If the sun went through one of its periodic conniptions with the strength of the Earth's magnetic field was turned way down, a solar flare or storm would have sent a burst of radiations that could have massive consequences for people living back then. This might be what drove them into caves. So that foreshadowing paid off. They're basically saying if this happens, the daytime becomes very unpleasant outside. And we're not just talking about for a week. For 400 years, the outside was widely unlivable, unpredictable, and chaotic. We're talking like not really fires in the sky, but the northern lights, the aurora borealis and aurora australis were everywhere. It probably looked crazy. There was northern lights all over the earth, and during the day there was probably electrical storms, no ozone layer, so you get sunburn or carcinoma in a matter of seconds, and a lot of animals died off. Also, probably some of the animals probably died off due to the sun, and some of the animals probably died off due to getting lost, because we know a lot of animals can sense magnetic fields and use it to navigate to their homes or breeding grounds or whatever. And a lot of those animals would have been fucked when this happened. Is it going to happen again soon? Probably not soon enough for any of us to have to worry about it. But yeah, I mean, maybe in a couple 100,000 years, if humans are still around, this could happen again. Let's see. Let's take a look at what here's a representation of the sun's magnetic field lines. Normally, they go out into space and save us from the solar wind. The magnetosphere surrounds the planet, originates from the hot molten metal in this iron core. That's the liquid flowing around, sloshing around, blah, blah, blah. And the magnetic fields shield us from cosmic rays and sunbeams. Here's a good picture of the anatomy of Earth. In the inner core, which is 1,000 miles across, is a big iron ball. That's the inner core. The core is a metal, liquid metal, sloshing paste of super hot liquid metal sloshing around the inner core. This is what causes our magnetic field lines and makes compasses work. Then around that we have the mantle, which is lava, various things, not quite as hot as the inner metal layer. And then the crust. It says here, by the way, let's see, the crust is maybe 100 feet down, a couple 100 feet down in most places. The lowest, not feet, miles. The deepest humans has ever drilled is just under 12 kilometers, and that took 20 years. So we're not even close to making it to the mantle, or much less the core. That's going to take another couple years of drill technology. Le Champs excursion is the name of a place in France where we have some lava rocks that were lava that apparently erupted and dried during this time 40,000 years ago when the magnetic field was reversed, because it's going the wrong way. There's lava pointed in the wrong way. This article is about how scientists spell it wrong. Big deal. But somehow there's no pictures of lava at the Le Champ excursion on the internet. I think geologists have really dropped the ball on this one. One final thought on magnetic spheres. I remember seeing one of these at an exploratorium when I was a kid, a turbulent orb. This is a ball filled with liquid that you can spin around, and you can see sort of clouds forming inside. If these look like a planet to you, like pictures of Jupiter or Saturn that you've seen, it's not a coincidence. It's kind of a coincidence, but those are big balls of fluid that are spinning around, and they have different flow patterns on them. And sometimes the flow is really smooth. We call that laminar flow. Sometimes the flow is really turbulent and chaotic. You can see in this picture at the top here. If you're just listening to this, we're looking at a YouTube video of turbulent orb, an exploratorium little demonstration. That's really cool. And you can see now as the orb slows, the clouds become more turbulent. And you could sort of picture, I think, what might happen if our inner core of the Earth got that turbulent. The Earth would hold together, but that laminar flow might flip upside down, and that would really suck. If we were around, not just compasses, but all geosynchronous satellites would stop working. Probably a lot of electronics would stop working. Cancer rates would go through the roof. A lot of animals would become extinct very quickly. Let's hope that doesn't happen until someone else has to deal with it. And if you're in the far future dealing with this right now, all of our hopes and prayers go out to you. And if you have invented any sort of time machine telephone, give us a call. Tell us how it is.